Hi everyone, welcome to the part 3 of the Serpano stream, assembly and bring up. And it seems we already have a few people here, but let's wait a few minutes. I thought, since I always kind of awkwardly start things, I could use this moment of time to self-promote, because that's less awkward maybe. So I put some links in the description to this video. One of them is my Twitter, so make sure to follow if you're not following yet. There's also a Hackaday.io link there for the project for this, for the project page for this page, so you can follow the project there. I post updates and post logs when the next stream is gonna be, so that's a good way to follow. And I also posted a link to my Tindy, which I haven't mentioned in quite some time. So I have some boards that I'm selling on Tindies, and if you want some cool hardware or you want to support me, check it out. Maybe there's something that you like. So let's see what's happening in the chat. I see we have Mark. So hi Mark. Hi Deshipu and Daniel, Rotter, Henrik, Johnny. Hi. Simon, Dren. Hi. We have pretty good numbers today, so that's cool. Hi Brian. Let me know about the audio, because I still have the microphone a bit further than it should be normally. So let me know if something is cutting off or how I sound. Hi William. Sounds good. That's good to know. Yeah, I adjusted the gate a bit, so hopefully I don't get cut off if I talk too quietly or for whatever reason. Yeah, so if you have looked maybe on Hackaday or followed on Twitter, you know that I actually managed to get the bug that we tried to bring up on the previous stream. I got it to work. It required quite a few bodges, and I assembled a whole new board, because that I didn't have trust in the first one. Maybe the soldering was, something was wrong there. But even after a new board assembled, I replaced the inductors with more common ones. The inductors I originally used were based on equations from the datasheet, and I thought I was, being smart, using the proper the proper values for my needs. But maybe that's something I should put for later. So for now, I put more common values that are more in line with what's in the reference design for this chip. And then I added some caps, which I might have forgotten to put. What else? Yeah, so the volume is at max, at least in OBS, and I don't know if there's much more I can do. Let's see. Because I don't want to also make it sound, I don't know what's the word for that. Like a photography is overexposed, but the sound is what, over something. So I can increase this here. Hopefully that helps. Right, so like I mentioned, I fixed it between streams, and I can show you the bodge city that I created during that. But today we will focus on the MCU. So I have all the parts here, hopefully, and I made some notes on my printout here, that which parts are which values. So hopefully that goes faster than last time. And it's more common values. So I will be using my common value box here more. So hopefully that goes faster. Actually, let me just get the soldering iron going. Because we will start with the hot air, as is tradition. Because we need to start with the ground pad. What should work? Yeah, I had to stack some things on things on things on things, but if it works, then it works. As I said in the previous streams, this is more of a function, like it's a prototype for testing all the designs. So it's not close to the final design, and I will probably flip all the pins that are on the breadboard 180 because right now they are the same pin out as an Adafruit feather. But if you wanted to use a Adafruit like a feather shield, problem is I don't implement some of the power pins here, so you couldn't really use a shield without it trying to go on top of the board, which won't work. So if I flip all the GPIOs 180, then you can use a feather shield or a feather wing. That's the proper terminology. You can use a feather wing just kind of backwards, and that should work. So we'll see how that goes. Yeah, hi Adam. Hi Henrik. Anyone else? Yeah, so let's switch to the microscope view. There we go. So yeah, like I said, this is board number 2. I have to resolder all this jazz. And then I actually soldered the button correctly this time, so it being down is on. So that's lessons learned. And then if we flip it, just a moment. Come on. There we go. Yeah, I also noticed I kind of skipped around the previous video, and I noticed with the microphone being so close, you can definitely hear every little noise I make. Like opening the plastic bags was sounding really loud, so I'm gonna try to open them now to the side. Hopefully that helps. But this is the Bodge city that I created here. Focus. So yeah, we have the main chip, and then we have these huge inductors here. That's the only size I had. Ah, hi Philip. Welcome to the stream. And yeah, I had to add some caps. Luckily, I had space here when there's ground and the voltage. It's 2 caps. You can heal. That's just the chair. That's always the excuse, right? And yeah, the clearance here is not great, but they are not touching, so it's okay. And as you can see, there's many components missing, so I tried to, based on the reference design, I tried to make the minimum working design kind of assembly. So I removed pull-ups that were not needed or optional, and I just defaulted the mode here, just pull up, leave it to auto start, so I don't have to actually use the enable pins. So later, when most things work, when most thing works, yeah, I will come back and try to play around and see what I can use and what's wrong and do more measurements. But for now, I just wanted it to work good enough so I can continue. So very interestingly, yeah, it's a sparring cup. Exactly. So I was gonna mention I skipped the VDiv here if you watched the previous stream, which is really strange because now nowhere in the datasheet it actually says that you can skip it. But then Conrad, which you might remember from previous stream, he brought me the multimeter, which I was missing. He actually also designed a board with this some time ago, and he just skipped those resistors totally in his design. I don't know if he read somewhere that it's possible or he just went for it. He couldn't really remember, but it worked for him, so I just went for it also, and it works for now. It could easily. Well, I had I had less parts on the floor, but yeah, it might be like that. Yeah. nothing is backwards also, so it might be better than the pick and place. But speaking of Sion, I will try to, I guess I should get going, because Sion is streaming in 2 hours and I'm trying not to collide with him, so I guess I will try to keep it down to 2 hours. But if we go above, I won't blame you for going to his stream. So I guess we should just start going. One more thing that I will just point out is this nice construct here, which is 2 resistors as a, I don't know, triangle on top of a capacitor. But if it works, it works. Okay, Sion is streaming at 10:30 and now it's 8:12. So that's in, yeah, 2 hours and 15 minutes, if I'm correct. But we'll see how it goes. Yeah, so it's not really a ladder, but I just didn't have the proper value that I wanted. So I just used 2 resistors just in series. So I got the total resistance near what I wanted, which is, it's strange because I based my resistor values on, okay, this is not great. Again, I based the resistor values on the equations that are in the datasheet, so they should be like exactly perfect. Like it should give me 3.3 and 5.0 volts, but somehow I had to put the values slightly higher for it to work. So something is not quite right, and we will see even if, hi James, and we will see if the board, if the chip even works, because maybe still it doesn't work, it just works without any major load. I put some resistive load to test, it seemed to work. We'll see. But I guess we should get started then, so we don't overlap too much with Sion. So we will start with the main chip here, and that chip is a, let's see, yeah, it's at 80 SAMD51 J20. Like I mentioned before, it's not a given that this will be the final chip. It's just something I know really well. I designed quite a few boards with the SAMD family, so even this design I just dragged and dropped from another board, so hopefully it will just work. We'll see how that goes. Planning about just checking out the chat, but we will. So you can see here I did a sin, and I put vias. Where's my pointer? I put vias between the pads and the ground pad, but it's a legal one, because you can see the pad here is actually fairly small. So this area it's fair game. Like you can put vias there, it shouldn't short. It should be fine. Yeah, misunderstanding of Ohm's law, but I mean, there were equations in the datasheet that said, put your voltage here, and here are your resistor values. I did that. I thought I was correct. Maybe not. Yeah, I'll circle back to that. I just want to see something on that screen, because that, you know, it's nice to have some win from time to time to keep you going. Right. So I should have actually preheated the. I should have preheated, because I still need to put some solder in the middle, and for that I need the soldering iron. So let's give it a second. Right, here's I can show the previous board, the first one, where I also tried to put some more caps, but then I still use the old inductors. I skipped totally the 15 volt. I was injecting the 15 volt directly here, just to make sure that it's not the fault of the boost. But yeah, something wasn't quite right with this board, or maybe it was the inductors, or There's so many things. But you can see traces. It might be because this board is 4-layer, so you will notice I don't have a ground plane on top, or is this the bottom? I don't have a ground plane on the outer layers. I have a dedicated ground plane inside, which allows me to route things way tighter and yeah, just have it way easier. But here we're also kind of lucky because we have vias, so if there's too much solder, it will just escape to the bottom through the vias. And also, even if a bit spills, it should be fine because we have more space around, so hopefully we'll be fine. Let's see. I want to frame it nicely for you. Focus. Okay. And then we apply a bit more flux, but it will evaporate anyway. And then we go for the hot air. I will try to move the microphone away, but it will probably be loud still, so sorry about that. I'm not sure if you can hear me, but I lowered the temperature. Now it's 380, which is still quite high, but it has proven to work quite alright. There it is. Okay, hopefully that should do it. Let's give it a moment to... Hi, Enwi, is that how you pronounce that? Oh. Damn, that did not reflow. I should have pressed more on it. Yeah, that's a bit too much. We can clean that later. I think we can salvage that still. Yeah. Just checking out what's happening in the chat. Right, so we should be able to fix this. Should be fine. Ah, Spaceback, hi. Right, so hopefully there's no shorts under. You can't really tell. Where's my... I always forget that I use the flex marker to put my board on an angle, and then I forget where I put it. Can't find it. I guess you can't really see it. Hi, Dustin. Ah, thanks for sub, Envy. Ah, I like me a good drag solder. See who said QFN are to solder. All you need is a 300 euro microscope. Easy peasy, right? By the way, the link, an affiliate link for the microscope is in the description if someone wants to buy and support. What is this dirt? The heck is in this solder? I think that's not enough. It's not properly soldered there, but let's circle back to that. Side is a bit annoying because this is in the way, the button pins from the other side. So let's have a look. That's the wrong chip. There. Yeah, so that's connected, but I feel like it could use a bit more solder, so we're gonna have another go at that side. Then focus. And this side looks pretty good. Let's have a second. Go at it. You can see as you drag, the pins are kind of stealing the solder from each other. So it's good to put more. Just enough so all of them have enough, but not so much that they short. Like we have here, there it is. Yeah, no worries, James. As you can see, this whole side is under soldered for sure. And yeah, I did put some solder on the other footprints here, but that's no problem. We can clean that up later. Right now, the chip is the #1 prio. Because the problem is that the chip is slightly off center, so there's not that much on the outside here. There's not that much place for the solder to attach to, kinda. Where am I getting this brown goop from? I think that should do it. And which side we haven't checked yet, I think. Yeah, this side was right, was good. And I think this was the last one. Yeah, I think we're good on this front. Looks like quite a mess right now. Clean up here. I guess some pins that I just clean up I will lead again anyway, but I do it on my terms. It's better. Right, we will also need, if we want to run CircuitPython, we will need the flash here. But let's leave that for the last. Let's first confirm that we actually have any live signs, live signs from the chip. But first we need all these passives here. So let's go for that. Whoa. So we have a 10K pull up here, or pull down. I don't quite remember what this one was for. We can double check on the schematic. Right, this is for the reset. So this 10K pulls the reset up, which there is, I think, an internal pull up anyway, but it's better safe than sorry. Oh, hi, Colin. Okay, you do, all right. Like I said, I copied this from a different design I already made, so I might have forgotten by now. And yeah, I just copy what worked before. And then we have a 1K, and that is, I believe, a pull-up on one of the single wire debug pins. I think it's on the clock. Yeah, the clock needs a 1K pull-up, which is quite unusual. Usually these ARM chips have a built-in pull-up. Like Nordic chips or STM, you don't need any pull-ups here. And I shouldn't... That actually goes here. Should pay more attention. Do we have any more resistors? Yes. So we have the I2C 4.7K pull-ups. Yeah. Right, I could... Oh. My top view camera is frozen, I see. Not that I really need it right now, but it would be nice to have it working anyway. There it is. Just wanted to show off yet again my nice system for what is it called? Common values. So I have resistors here and some caps and some LEDs and stuff like that. So I can quickly, I don't have to keep those in separate bags and set. Okay, never added it because I know. I think I had a design before where I didn't have it, and it definitely did not work. I had to add it again. I don't know if it was SAMD. It might have been a Silicon Labs Gecko something. I think they also require this pool. But yeah, I usually just listen to what the datasheet say. How's my pick and place going? It's going slowly because the postal system is super slow. So I have it assembled. I have it almost more fully assembled, except for the actual rails that move the nozzle up and down, which is like you cannot. It actually keeps the nozzle attached to the carriage, so without that I can't use it at all. And those rails I ordered mid-May, and they're still on their way, so it's really bad. But other than that, it's assembled and all the parts are working, but that's the last part I need. I'm hoping once that arrives, I can get to it. Okay, and then a crap load of capacitors. Oh, there's actually two more resistors. And that is USB resistors. I put 22 in the schematic, but I have 27. That works too, as long as it's in that area. Everything is really sticky here because of the flux. We'll clean it up later. Okay, and then we switch to all the caps. You can see how sticky everything is. Not great, not great. So these are these are 10 microfarad, and I actually need 2 more of these. I'm gonna already prepare them. 21 online, not bad, not bad. Yeah, I know Steven in his latest video. You should follow Steven for sure. Go check it out. Someone, or Dave Darko, you can post his channel link. Since you're a mod, you're allowed to post links. But he redesigned pretty much the full frame design. So I have to reprint everything. I mean, have to. I don't have to like start with that. I can first get it to work with what I have so far, and then reprint. But yeah, it's been so long that he redesigned most of it. On here, and then I'm always a bit unsure how many cups are not enough and how many cups are too many cups. Here I try to follow the datasheet, but the datasheets usually they're paranoid, so they tell you to put way more caps than you actually kind of need. I mean, obviously you could probably run most stuff without any caps, but don't do that, please. And then 0.1 UF, we need 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's just kind of, that's some number of them. Oh, that's a very flat one. You can see that I took from different reels when I was filling up my containers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, that's one too many. Okay. The tweezers are, these are the SparkFun tweezers, and I definitely recommend them. They're super nice to use compared to, I have some more here, like these are really cheap from Banggood or something. You can see here, and I don't know, I really like the feel of these SparkFun ones. I definitely recommend, and that's something you don't really buy every month, so even if they cost a bit more, I would recommend. Yeah, they have two kinds. The ones, I don't know how to describe them. One of them are narrower, and then the second pair is a bit more wider, which is nicer for grabbing larger chips. Like you can see here with these, I can grab, or you can't see already. I can grab this chip and slightly larger, but there's some QFP that I would not be able, and for that, the second pair is really useful. So I would recommend getting both. And yeah, you can get them from SparkFun, or you can get them through Mouser, probably DigiKey. I got mine through Mouser, and that works for me. Probably Adafruit has them as well. So many caps. Yeah, we have a quite nice electronics store in Malmö, ElectroKit, and they also sell like Adafruit stuff and yeah, from different stores, from Pi Moroni and so on. But yeah, their prices are not great, so it's definitely cheaper to order directly from other places, but you can't beat that 1-day delivery. So if you're in a pinch, you can go for that. So this cap is not really needed because that's a decoupling for the display, but since we're already here, and this is, oh no, that's actually for this, so that is needed. So what do we have left here? 1, 2, 3, 4. This is a 4.7. Yeah, before the pandemic, you could also just go to let me approve that comment. Not sure why that got blocked, spacebar, but I don't blame you. If Carl, I mean, you can mute me, and then when you watch that video, unmute and continue watching. You don't have to leave, you know. Yeah, so as I was saying, before the pandemic, you could actually just go there and pick up your parts, but now they closed their physical location, so you can only get it delivered. But it is next day delivery, so that's really nice if you're kind of desperate. Are you teasing me, Adam, to try to pronounce his last name? Yeah, he's from Malta. Okay, so last part, I believe. No, 2 more. What did I? Ah, there was another 4.7 I missed here. Yeah, I'm really impressed with if you don't listen, if you're not listening yet, no. If you're not following the Hackaday podcast, you definitely should. It's great content. They every week summarize best articles from their page, and they have really cool discussions. It's Mike and Elliot, and I'm really impressed that Mike can pronounce pretty much any name. I think he might try a few times before the podcast, and then he just makes it look easy. And then we have a nice ferrite bead to clean up that analog signal slightly, because I will be using the ADC here, so that's another thing I have to test. How good will the ADC behave? I know the SAM, the ATSAMD ADCs are pretty good, but you know, they are only as good as your analog design. and I'm mostly a digital guy, so we'll see how that goes. It's not so hard. It's like Shis surname, but I know it scares many people because there's a lot happening there. Yeah, it's like the actress who played Wonder Woman, Gal Gadot. It's like that pronunciation is also quite interesting. Is the T at the end there? Do you pronounce it or do you not? There is a video I know that it's just clips of her for a few minutes, just pronouncing her name in different interviews, and yeah, that's another one that's like kind of you listen and then I don't know, I still not confident enough. But luckily that name doesn't come up that often, you know, at least in EE conversations, so safe there. Yeah, Mark, my real name is super secret, so no one knows. All right, we are done here. It looks like a total flux mess. Saoirse Ronan, yeah, that's another one. She was on Seth Meyers a few times, so I kinda know how to pronounce their name. Maybe not. It's Scottish, right? Or is it? It's out there. Irish, yeah. I don't know if Brian is still here. I better not confuse Irish, Welsh, and Scottish people. He will not be happy. Yeah, Welsh is a whole other thing. Yeah, that looks alright. So, should I try it or should I solder the... I think I will just try to connect to it with OpenOCD, and if it connects, then we will solder the flash. So on this side, you can see here I have nice test points for the SWD and power. And those test pads are smaller than they looked in KiCad. And isn't that always the case? We'll set up some cable here. I don't know how pretty I want to make it look. I will probably be debugging a bit, so I want it to be usable more than once. not sure that will actually work. Yep. I should get one of those. Your neck hurts. All right. Should get one of those isolation strippers. Should I switch? I don't know if this is more. Because you can kind of see what I'm doing. Yeah, not quite. Oh, I thought you meant that I'm at showing at 90 degrees and that's why your neck hurts. Which is fair. What is that emoji? I can't really see on my tiny screen here. Sure, that kind of works. It's an owl, right? Yeah, nope, it's too small. I have a setup that I haven't really tested that much, that I can stream my laptop screen. We'll see how that goes, because I use my laptop for development. Yeah, I got that. Yeah, I gotta admit, I didn't really think of usability here when I made these test pads. They should have been more vertical. That's pretty terrible, but hopefully I don't need to use it too much. Yeah, if I recall, we can check it. Whoops. I just cut that tracer. I think that's the reset, so hopefully not. Yeah, I think it's fine. and now it's nice and exposed. Yeah, I use them once unless I wanna flash more firmware later without UF2 or something. I think I designed this to be... Yeah, exactly. I did put this 0.1 inches apart so you can use like a standard header here if needed. So that much I thought about. Which was this? 51. I have this board that I haven't really shown anywhere yet, even though you can see it's dated May. And this is a tiny DAP. So this is my CMSys plus UART board. I still need some UART software to write on it, but it should work for OpenOCD. All right, I made this USB Type-C. I forgot. I'm so used to these debuggers working on micro. There we go. Okay, let's see if I can stream my laptop. And if there's smoke when I connect the chip. Okay, so that is definitely stuck. Let's see if we can fix it. Okay. There we go. So that is my laptop. It's not sure you can see much there, but at least you can see something happening. There's the board. Actually, I have it backwards, so I can't really touch the chip when I connect to it, because I want to give it the all touch to see if it's hot test. It stopped blinking, but it's because, yeah, I put a space in there. Okay, it's not hot, so that's a good start. That's something. No. Okay, so this is actually too big, but we do have it is connected now. Yeah, so that's great. So does UF2, because UF2 only flashes to the internal flash, so I think I should be able you can read it. Yeah, I'm not sure how big it has to be. something like this. Because I should be able to actually flash UF2 to it now. Let's do it. And I think I'm gonna just flash the one I have here for a feather F4. That should be good enough. Now I need a new touchpad because this one gets stuck sometimes and just starts floating, as maybe you saw. Right, so now we have a UF2 on it. So now we could actually try to connect the USB and see what pops up. If I don't try to connect the cable into my Ethernet port. There it is. So that's not quite, but I guess it does, yeah. Yeah, UF2 is the bootloader. But I'm wondering, do I need to, because it should pop up, I think, even without the flash. Or maybe not. Let's just shoulder the flash, because yeah, something was trying to pop up there. You can definitely see that, but it failed. So let's just hope it's because the flash is missing, because the chip was definitely working. So let me put this back. It actually worked out quite all right. And let's switch here maybe. It's too dark. Come on. Okay, let's switch here then. So here's the flash. And yeah, let's start with that one then. Yeah, bye, Simon. Thanks for stopping by. Yeah. So the actual bootloader is Adafruit's fork of Microsoft bootloader that supports the UF2 format, which is, yeah, it's a container for firmware. That is way too much. But yeah, I just call it UF2 since that's the file format. Because you can see there's no via here, so we have to be a bit more careful. Actually, I usually flash these with not flash. I usually solder these with paste. So I think, I'm not sure if these chips actually have pads on the side. Then we might have to hot air the whole chip, not just No, okay, we're good. Yeah. Right. So the chip I have here, the flash I have here, you can see it's a 128 megabit because that's what I had. 64 would have probably be enough, but 16 megs, that's a few files. And the hot air is back. Yeah, you know what, this footprint's created for solder paste, so it's too small. I wouldn't be able to access the side pins to solder them by hand. So we're gonna just have to reflow the whole chip. It won't explode. Yeah, this is interesting because I don't think I actually ever soldered on this footprint with hot air. It was always paste and then oven. So that's new. Yeah. Yeah, I'm not so sure about this one. I think we might have to go for one more round with more flax. Is it fine? See, now I think that's better. Everything came out on the side, so yeah. Can't tell if that's really good or that's really bad. It's something. Except this one, which I think is CS, because there's a pull-up on next to it. You don't need a chip select, right? Yes, I already... No. Oops, that's too much. I think this is as far as this adapter goes up. It's a bit further now. But you can still have pretty good zoom. I definitely see more, yeah, in my eyepieces. But overall, you can see a lot. It's just that I zoom in a lot. I don't want to push on it too hard because then things might short. But I think this is good enough. Oh, let's see. So now we just need 2 more components and let's see what's happening. Oh man, that's really blurry. There it is. Yeah, the drawer is great. We're actually doing pretty good time-wise. Like it's been an hour and a half, and we soldered something, and something worked even. So now, okay, let me just solder this up. Hi, Gerald. Yeah, I guess it's an hour and 7 minutes until Sion's stream. Oh no, what if Sion copyright strikes me? Or do you want to see Arturo react to Sion stream? These again, the stick vise with the PTFE jaws is great. I put so much heat, 300 degrees, and it got just slightly brown, and now it's clean again. So it's a really good investment. Nice, 0.5 lens adapter. Nice. Yeah, I have another. It's another place because I got two adapters with this one, but the other one doesn't have the focus. Like with this one, I can focus independently from the eyepieces, even though most of the time it's kind of fixed and then it follows the eyepieces. I like this option to have it to quickly do that. Brian, you have been here. I thought you went away because you didn't yell at me when I confused Irish with Scottish. That's not great here. Yeah, don't buy Charm High, I would say. He did not have a great experience with them, definitely. So if you can support Sion also. And yeah. Scam High. It's pretty incredible that what they can get away with. Even with Naomi shaming them publicly, they didn't seem to care. Yeah, I don't know if you heard it so many times from Sion, you don't need me to repeat what he said. Yeah, why did I do this? I don't know. I get ahead of myself. So let's try again with the flash. Actually, first just a sip. Yeah, thanks, Dave. Let's see if it broke. Yeah, this HDMI capture is not happy, or maybe it's my laptop or something. Okay, we're back. So let's see again what happens. The power button is now it's on. Ah, there we go. So it found the feather. It found an 8 meg. Right. So this flash, I installed a 16 meg one, but I'm using the UF2 from Feather M4 because I'm lazy to now change all the values. So that's good. Checking, sorry, reading the chat. Right, so what we can do is I'm just thinking, should I also get lazy with the CircuitPython and just copy over the one from Feather M4? I think I can start with that, and then we can go from there, because I don't think anything will break. So I mean, obviously the GPIOs will be all wrong, but if I just want to, you know, get the repo, yeah, let's do that actually. So I will leave dmask here. I have CircuitPython open here. I guess that's big enough. The nice thing with device is that, I mean, my board is super uneven on the bottom, so I wouldn't be able to solder it if I just put it on the desk. It would wobble all around. Device also gives it extra weight, so it stays in place. And another thing, that this base of the microscope, it's metal-ish, so I think it would short stuff if I'm like, right now I have it connected, there's power. So that's why I've used a vise. And also I can, as you saw, I can use hot air on it and it doesn't even twitch. I think your desk wouldn't be as happy with the 300 degrees on it. Just something to consider. Yeah, it's a SCSI removable disk. It is. Actually, it's Adafruit, CircuitPython, Feather. I should get a newer one. Actually, let's do that right now. Yeah, I don't use Chrome, so I'm good on this. Oh, right. That was also IMX Feather. I didn't even notice. Yeah, and now we wait. And then we wait some more. And then we get worried. That's unusual. It usually let's do a sync. It usually unmounts when it's done and just reboots. But okay. Interesting. So maybe it actually interesting. Why did that happen? I'm wondering if the flash config is different, so it will actually not be happy. Ah, this is sorry. I mean, that shouldn't really matter, but sure. And then exactly, because that's not configurable how much flash you have, because I think that flash is the internal. That was that link, Dave. Nice, Envy. You can use it vice versa. I wonder if it's the CS chip, it's the CS pin that's actually stopping the CircuitPython. No, because if CircuitPython was, the code was there, but it would fail, it would not show UF2. So something is not quite flash. No, exactly, because you can see like the flash is actually not configured in the bootloader. And I don't think this should matter. So that should work. So let's try that again. We are very close. I can taste it, but not quite yet. How is my voltage? That's a good question. But see, even if the CircuitPython was wrong, there's still something not quite right, because UF2 should reboot when I copy over the UF2 file, and it doesn't reboot. So something is not quite right. If we disconnect, right, now I have to switch USB cable again. It's It's going pretty well, James. And as I said that, nothing happens. Interesting. So after the new bootloader flash, it does not show up. I wonder if it's trying to actually start the CircuitPython now. Oh, Sion, hi! Welcome. So I think it might be that now it's trying to start the CircuitPython, but it's failing because it's for the wrong board. So I will need... Oh no, actually I can do it. Because I was thinking I need the power button, the reset button to enter UF2. But what I can do is actually erase flash over CMSys and just start all over. So let's try that. So I reconnect this one. Wait, did my USB just die or something? Because now it's not even showing the CMSys. Yeah, exactly, but I don't have the reset button soldered. So it might be easier to actually just erase the flash. But now my CMSys device is not showing up. So I'm not sure what the heck is happening right now. Should I try it? Maybe I'll try a different board. Did my USB just die totally, or is it my cable? I will just... what else can I connect? Just any random thing. Computers, am I right? Okay, so this shows up. So is it actually the cable? Oops, sorry about that. I will try a second cable. Even though it's a Type-C cable, those never fail, right? There we go. Yeah, I connected and it's not showing up. I am confused right now. Okay, so I have a different debugger also. We can try that one. Where did I put the cable? So this one is a totally different debugger, so let's try with this one then. Yeah, reboot will take a moment, so I would rather not. Okay, so this one shows up. So I'm not sure. Problem with this is my cable is now short. Okay. Let's try it again then. So we start OpenOCD, it still connects. What was it? Flash. This is not something I do very often. Is it like now? Does anyone know? I feel like there was some way to erase easily. Okay, so that should have erased maybe everything. That doesn't sound like that many sectors, but I don't know how large sectors are. Yeah, in JLink it might be, but here. Okay. Or actually, we don't need this. Shut down. Okay. Then I still need a Type-C cable here. This is supposed to be this easy part. Why is this so? Okay, there it is. So that's the UF2. So what we're gonna try to live stream now is porting CircuitPython to a new board. So this is the pins, we can skip that. Here, right, so there you go. So this might be problematic. This might be why it doesn't work. I don't think I am on the latest commit here in my local repo, so that might be why stuff isn't quite working just yet. Let's exactly, and I don't have a crystal, so that's like the first thing. If it was trying to run with external crystal, dead. Yeah, so that will probably do it. I'm actually not sure what this does. Right, so this, and then here we have to find the chip, and then I never remember what is the folder. There's a file that has all the chips, and I never. Okay, maybe I do remember. Okay, that was actually not so bad. So what was the chip again? If only I remember. W25 Q128, and there's JVI. Yeah, so there's two, and I never remember which one. I'm not sure if it really matters. I think the difference is the memory type here. Let's try one, and if that one doesn't work, then let's try the other. Right, that's how we usually do it. Okay, so this is how much it takes to pretty much port CircuitPython to a new board. I mean, yeah, you need to put more pin info, and like there's all this jazz here, but that's pretty much it in the short of it. Yeah, so now we build it. Did I mention Google at all? I don't know. So Sion, what's up? What time is it there? Isn't it like super early? Are you even earlier than usual? Because your streams, I think, start pretty early for you. Maybe it's my accent. I said something that sounded like, okay, Google. Okay, Google, set a alarm for 4 a.m. $5.50, wow. Okay, we have see, CircuitPython creates for us the UF2 file, so that's a simple thing. Okay, we have dmask here. Yeah, so let's see what happens. Yeah, so this time it disconnected properly. Ah, there you go. We have CircuitPython, which still says Adafruit. I guess I missed a string somewhere. Yeah, there you go. Ah, it's the right. Johnny. Henrik, did I set your alarm also? Sorry, I won't do that anymore. Yeah, so the string I use here is used by CircuitPython to display like in system info, but the string that's here is actually used by tiny USB to show what you see here. But either way, it doesn't matter. So now we are at TTY ACM1, and there you go. So we have CircuitPython running now. Yeah, thanks, Sion. See you in 40 minutes then. I will try to wrap up before your stream starts. Thanks for stopping by. Starts playing but hip hop music now. It's actually quite impressive that more TV shows don't trigger people's Alexas and Googles and Siris and all that. Okay, so the math still works. So what do we want to now? I guess we want to show something on the display, don't we, no? I think that would be fun. So we need to solder the header and 3 components, which I think we can do in 40 minutes. So let's actually do that. I will also solder the button so I can easily enter the bootloader. Because if you're not aware, the UF2 bootloader has this super cool feature where if you double click the reset button fairly quickly, it will enter the bootloader, and then you can just drag another file. But yeah, good success then. Let's switch to the microscope. So let's start with the button because that's faster. Famous last words. Right, so if you haven't watched the previous streams, there is a bit more left here, and I'm guessing we will leave that for the next stream. And what you can see here, this is the battery circuitry for the charging. Never mind that. So yeah, the battery connector, and then the battery charging chip, and that's pretty much it. And then here we have a NeoPixel, and here's the reset button. Okay, it's another fruit addition. Very interesting. I mean, for me, when I say UF2, I definitely mean Adafruit UF2, because that's pretty much the only UF2 that I have like done anything with. I do have my own tiny UF2 library on GitHub, which I use on the NXP IMX RT board to get UF2. And there I also implemented the double click, which is really great. I wonder if I have the buttons here. Was I smart enough? Yeah, okay. Yeah, it's too bad we lost Sion, because he might know more about the ESP32S2 CircuitPython situation. Because I have a board with the ESP32S2 that I want to run CircuitPython on, and there you can't use this double click thing because the reset actually resets. It's like a hard reset. So when you press the button, it erases or it corrupts RAM. So this way you can't, because the way it works is that on the first reset, it will write a value to RAM. And then that RAM is not reset when you press the reset button. So on the second boot, if you press again and that value is there, then you know you should stay in the bootloader. But on the ESP, RAM is lost when you reset. So you can't do this trick. And then I know Adafruit is looking into ways to fix that. I think they want to use like a capacitor. So when you reset, it charges that capacitor. And then, if you press it again, that capacitor will still have charge. So that's how you know you should stay. Otherwise, it will discharge and you don't stay in. Okay, okay, but yeah, I'm not sure. I mean, between the ESP8266 and the ESP32, I guess a lot has changed. So maybe that doesn't work anymore. I'm not sure. I haven't looked into it. That's only what I heard from Scott from Adafruit. But Sion has multiple boards coming with ESP32S2, so I think he might know more. No, exactly, not on the S2. Actually, where is it? Okay, because I thought I could show you that board, but let's not get distracted too much. Yeah, and that's And as I say that, I get distracted. We still have 2 more things here to test, to solder and test, and that's probably next stream as well, which might be, this is more interesting than the battery, so this will probably be the next stream, and the battery is in the 5th stream. So this is the I2C digital potentiometer, which controls the adjustable voltage. It just changes the resistance of the voltage divider. And here we have a current sensing chip with a current sensing resistor, and that's used to, so you can get information on how much current your breadboard design is using, which I think might be cool for optimizing power. Just something to test. Okay, so what we have here, right, so I don't even need to know the values because this is such a, I did this so many times that I should be able to see. This is the backlight control for the display, so we need this, and right, it's a MOSFET, and then this is a 10K resistor that makes sure that the display, the backlight is on by default, I believe I made it. And then here we have a small drop resistor for the backlight. So I think I put like 10 ohm, but since I don't have 10 on ohm, or maybe I actually do. Okay, I do have a 10 ohm. There it is. I normally put just the 27 that I use for the USB there, but since I have it on hand, let's do a 10. I mean, that just defines the ceiling of how bright, what's the maximum brightness of the display, of the backlight. Because you can still PWM through the MOSFET to control the brightness up and down, but the resistor just defines the maximum. And it could probably be 0 as well, but I put 10 kinda. I don't have a good reason. There, and then we put a 10K, which I have on hand. And I know I said it this many times, but I'm super happy with this construction I have here. There we go. And then actually, okay. And here we put a nice MOSFET. I also have a box full of them because I use them. That's a lot of MOSFETs. Because this is my MOSFET of choice. Yeah, the DC jack. It does indeed look like a face. But yeah, in these streams you can definitely see which parts are new to me, because I mean I think we're doing really well today with the bring up of the MCU, because I've done this so many times. So I know exactly what can go wrong and what to do. The other parts were not so smooth. There we go. And now this connector. Hopefully we can drag solder that one. Is the audio still okay? Because I'm seeing a message from YouTube that the audio bit rate is 0 for some reason. I don't know. What is it complaining about exactly? It's fine. Okay. Thanks. All right. I think I rotated, yeah, I rotated the camera when I was zooming out. Okay, now it's parallel. So much flex everywhere. Yeah, I'm not 100% sure we can drag solder. I never have good luck with drag soldering these kind of connectors because the legs kind of get in the way here. It's definitely easier on a UFN. See, it's not great. But on the other hand, we can just do an absolute massacre and then just wick it. Yeah. That went almost well. I mean, that's not exactly what I meant when I said drag solder, but we're dragging a solder and it kind of works. The problem with these ones is also you can't stay too long on one because they will start melting the plastic around them and start going strange places. So you gotta keep on moving. Yeah, that wasn't so bad. Yeah, I need more flags. Now it's too late. All right. That works. I always solder these open because once I saw a few times I soldered closed and it was like it was too tight to the board and then I couldn't open it. So now I learned to do that when they're open. There's something we missed on this side? Not really. I mean, surely there, but we're pretty good on this side. Yeah. There's a bridge. No, you're trolling. Oh yeah, there is. Or no, that's actually, I think that's just like, yeah, it's not a solder bridge. It's kind of like flux goop the same as this. Not very pretty. I don't know if my flux is old or something, that it's becoming this like dark brown goop under heat. It's not very pleasant to look at. Yeah, no worries. No, it's good. No, that's how I like it. So I have a few displays here. Can't really see. Yeah, maybe it is at 350 right now, the soldering iron, but it's because there's some pads that need that extra kick. So I like to keep it a bit higher. Okay, I need to do this. There you go. Right, so this will not... It's so bright in here, and this camera is really under... Just give me a moment. That's not really helping, that's just making it very bright. Okay, now we're in a nuclear explosion. Yeah, that will do. Okay. It's a bit... this camera... not as good as expected. Alright, so I was saying... I don't want this to get shorted by the metal in the back, so I'm gonna just put some tape on it. Better safe than sorry. I don't want to solder a third one by hand for now. Yeah. All right. I have made a board before with this display, so I'm fairly sure it will pin out is correct and it will work. I'm just checking does it align well with the silk screen. It's a bit overexposed, but well. Yes, that is my JLC PCB. I'm not sure if it's sponsored tape because they just throw it in for anybody, but that is a JLC PCB tape. Right, this is actually starting to look nice, especially with this overexposed camera. The gold really comes through. There you go. We can just indulge ourselves and put it on a breadboard for fun. If I can get the alignment correctly. almost. Okay, we have 15 minutes before Sion's stream, and even though he didn't say, he said don't worry. I think it's only fair to let you guys go if you want to go. There we go. Yeah, looks just like the render, right? With the wire and the tape and actually that's not a bad idea. If in the render I added some fake fingerprints, that would make it more realistic. There you go. Anyway, we probably want to show something on that screen that we can do, I think, in a few minutes. So did my laptop stop working again, or is it okay? Oh no, you saw my password. Oh no. Still works. And if we test the double reset, yeah. Cool. So that works. Why is no one liking what? Okay, let's get going here. So now what I have to do is go through the schematic and just assign pins. I think we will skip for now the irrelevant ones, which is all of them. I don't know how big it has to be visible. Right. So the backlight, which is not really priority, but sure. Right, the backlight is on. I don't think you can see it. Nope, you cannot, but it's on. Not sure if you can hear people honking outside for reasons unknown. We have LCD data, clock, LCD, reset, LCD, DC, all right, CS, and then LCD, DC. And I think that's all of them, yeah. Can you hear that outside? Let me know. Then I can close the window. I said honking, not humping, but it might be both. I'm not sure. A07 is LC. And then the data is A12. Then clock is A13. Reset is B12. Chip select is B13 and that's B14. Yeah, so that should be enough to actually get the... Okay, so you can only hear when I'm talking, but now it stopped, so it should be fine. So that should be enough to get the LCD working, if I'm not mistaken. Yeah. Yep. We could also do the buttons just to see that they work, because that's also fun to see. Something that you can actually interact with. They're all on A0 and it's 4, 5, and 6. Right. Very important. Skip this. We don't need the default SPI bus. Yeah, that should be enough for now, at least. That's really in the chat. It should be done in a few seconds. There we go. All right. So now I double press. We should be in UF2, and I should be able to just copy again. Okay. Then here it restarted. Still shows Adafruit, which is a bit strange. Let's see if we have our pins. We do! Perfect. So now what we need to do is copy some files, which I have. So we need the Adafruit, this one. That's the driver for the LCD driver chip. That's one of them. And then we need the bus device, I believe. All right, we need the text also if we want to run the demo. And then we have a simple test. So we can try that and see if it complains about missing more files. All right, so yes. So the default code assumes we have a default SPI bus, which we don't have. Oh yeah, I forgot I should change like a lot here actually. Oh, if only I remembered. Never remember the order, but they're named parameters, so we're good. sure that works. There we go. Okay, so this is for the not this size, so that's gonna be a bit crazy. It's not gonna be centered, doesn't matter. Ah, did you see that? As I said, it's not quite there because the example I have is not for this size, but what we can do is exactly we want. Yes, this is the one we want. It's for the same size that we have. So I will switch to the big one. Oh. It's telling me the pin is in use. Oh, what the hell? That's not expected. Let's play Doom. Is there a Doom for? Why is telling me the pin is in use? I guess right, because the display is still, yeah, right, release displays, that's the one I'm missing. Or did it already do that? Huh. That's strange. Yeah, it tries to reuse the pin, so I would have to yeah. But that's not even the problem right now. Why is it not printing in the middle? Did I mean 240 by 240. Right, you're right. Yes, there's an offset. Yes. And I didn't copy this line. I started in the next. Right, you're right. Thank you. There it is. That should do it. Connect. I will fix that later. Okay. I make make me? Is that make me what labs? Okay. Surely this will work. Okay, there it is. And go. Hey! Finally! And then if I reset, yeah, you can see the CircuitPython. Very nice. And I mean, the resolution on this one, 2 minutes left. Ah, no. Okay. Where was I? Here. So one last thing we can do is try the buttons. So the button is false. I don't remember. Yeah. Where is this? Oh, right, because it shouldn't be output, it should be input. So it's false, and if I press it, it's still false because it should be pulled. Is digital pull up. So it's true, and if I press it, it's still true. Ah, okay, so I screwed up either my schematic or the pin config. So when I press the bottom, the value changes. True, and then I press it, false, true, false, true, false, true, false. Yeah. So that one button works, and the LCD works, and now it's time. So I think, yeah, we will close this. This is a perfect point, I think, and everybody go watch Sion's stream in a moment. So let me just say thanks for watching. I'm really happy. I think this was a pretty good stream. We did what we wanted, what we set up for. Make sure to subscribe if you're not, so you get notified on the next one. In the next one, we will probably do the other power chips, the two. And follow me on Twitter, check out my Tindy, check out my Hackaday.io, do all the things. And now I need to press a button. Thanks so much. See you.